welcome everyone. I'm just admitting a few more people and then we're going to get started. So if you just want to grab yourselves that precious cup of tea, cup of coffee, Hayley and I have got ours at the ready, and it's time to just enjoy your Timstar webinar for the next hour. Just give it another few seconds. Got a few more people coming into the session. If you just bear with us. Thank you very much for everybody attending. Can't see faces, but I can see lots of names, little initials and dots on the screen. I think this is our highest number of attendees. So thank you very much.
Thank you for joining.
I'm just going to give a bit of a brief introduction like I've done in the last two sessions. And then I'm going to pass you over to Hayley from OHAUS. So again, for those people that have newly joined the Timstar webinar live series session, welcome. My name is Lucian McCallum, and thank you for joining us. And can you please mute your microphones and turn off your videos? But I think everybody's done that already. So this webinar is live and will be recorded. The recording has already started. So welcome to the Science Lab Live series, which is a free session, expert-led monthly live webinar focused on supporting high-quality secondary science education and Year 6 classes. Each session brings together experts, as we have Hayley Davis from OHAUS today as our leading expert. It also brings together science teachers, science technicians, and specialist suppliers to share practical insight, curriculum support, and real-world classroom applications. Just to remind you, if you haven't been on the session before, we will send a certificate out along with a list of products that have been used today as a follow-up on a follow-up email for you. So just a bit of background about me for those of you that don't know me. I have been promoting and supporting our Timstar Specialist Science brand for almost 20 years. I know it's hard to believe. Some of you may already know me. I have travelled the length and breadth of the country. I've done lots of sessions across the UK. I've done lots of sessions within schools, and I've done loads of events. So welcome again to everybody, and those of you that know me, a big hello, and those of you that don't, it's good to get to know everybody else. So Timstar have 4,500 products in our range, and it's expanding by the minute, with our lovely Mark Jeffrey, our product manager, who has been covering our chemistry, physics and biology range. And he has been adding to the range, and hopefully we're bringing back a catalogue, a full catalogue this year. So that should be landed with you at some point. We have got exclusivity with BMS microscopes. We work with Edvitech on biotechnology kits. We've got iSchool that does all of our glassware. OHAUS, obviously with Hayley here today, that does balances and pH probes. We've got Lascelles physics kit and so much more, chemicals, glassware, and the list goes on. We're bringing the resource hub up to date as well with all our practicals. There's lots of information on there for you to get access to on the Timstar website. Lots of content, a wealth of practicals, and there's also funding and buying guides to help you with your roles and secure extra funding for resources. So we've got Timstar along with our other specialist brands, Modsport, PE and Sport, Gresswell, Library Furniture, New Builds, Refurbs and Projects. We've got Technology Supplies that does all of our design and technology equipment. For those of you that are unaware of the acquisition, Commercial Services Group bought our specialist brands back in February 2025. We are no longer known as WF Education. We are a one-stop shop with the addition of our other brands in the CSG portfolio, including KCS Education, who've been established since 1930, so a long time, and are the leading supplier of educational and early years products to schools and nurseries across the UK. We have almost 15,000 products ranging from stationery, curriculum materials and furniture, and we recently acquired Landscapes for Learning, supplying durable and affordable wooden outdoor furniture from nurseries and primary schools. So we offer the full range, but we encourage you to please visit our websites for further information on each of our brands and have a look at our fantastic range of products. Just to make you aware, we have the largest field sales team, so we're here, we're there, and wherever they're out to help you. Fantastic customer service team, the fastest and most reliable delivery service. We are excited and eager to help and support with your everyday needs and make your life that little bit easier. We're running the Timstar webinars every month throughout 2026, and just a reminder that we do the Timstar Tuesday discount days, offering 10% off online orders. Now, you can come to us if you need any help and support with orders, quotes, queries, and we will do our very best to assist you with the best price on our products. So we encourage you to talk to us. We would love to hear from you, and we'd love to have any feedback around the webinars as well, or any sessions that you would like us to come and attend at your school or at any events. And we're always happy to help. So I'm going to pass you over to Hayley, who is from OHAUS, who is going to do a fantastic session for you, and I hope you enjoy. Hayley, over to you.
Thanks, Lucienne. So I may have met some of you at some of the technicians meets that I do with Timstar and alone with OHAUS as well. My name's Hayley, and I've been with the company for just over a year now. You may know OHAUS predominantly for weighing balances, weighing scales. You may have some of our balances in your lab, the Scouts and the Navigators maybe, and the Compass, even some older units, some Travellers possibly somewhere. We do also do a range of lab equipment, and some of the equipment is supplied into education. So we have hot plate stirrers, we have the pH sticks, we have little tiny mini centrifuges. What I want to talk to you about today is pH. It's used in many areas, and we'll go through some slides in a second. And we have our own range of pH testers. So these are the pH testers that you pop in, you get the reading. I'm just going to give you a bit of a kind of overview on pH, why it's important. And I'll get these slides started. Let me just share my screen. So I hope you can see that. There we go. So practice for pH perfection. What we're going to talk about today is what is pH and why it's measured, the pH measurement principle, some good practice, pH sensor care and calibration, and the pH measurement practice. And I can just show you briefly the OHAUS pH range as well. So what is pH? It's essentially a chemical property of a solution that dictates whether it's acidic or alkaline. Acidic or aqueous solutions taste sour and bitter. Think of your lemons, and apparently Coca-Cola, before it's popped in with the sugar, apparently before the sugar's added, it is very, very sour and bitter. And alkaline aqueous solutions, they taste caustic and they kind of feel like soap water. On the top here of this diagram, you'll see the kind of everyday products that we use and where they sit on the pH scale. Everything from your lemon juice and your Coca-Colas, down to the acidic, on the acidic range, and your stomach acid should be somewhere around here. And then there's not really that many day-to-day alkaline products that we use. We've got sort of egg whites, antacids, toothpaste. Actually, somebody mentioned in one of my seminars the other day, so you'd probably find toothpaste up here on the alkaline scale somewhere. And then at the bottom is the acids and the alkalines that you're probably more commonly used in the schools, in education, in the labs. So you've got your sulfurics, hydrochloric, acetic acids, and then in the alkaline side you've got your caustics, calcium carbonate, your ammonia solutions. Why is pH measured? So measuring pH, or potential of hydrogen, it's essential because it quantifies the acidity or alkalinity of a substance, which can directly impact a product's characteristics. It can affect the shelf life of pharmaceuticals. It will affect the taste of food and beverages that we consume on a day-to-day basis. It can affect chemical reactions, biological health, and lots of other reasons. Where is pH measured? So too many to mention, but here's a couple of examples of where pH measurements are important. Drinking water. So you have to monitor the drinking water to make sure it's neither too acidic, which can leach toxic metals like lead from pipes, or too alkaline, which can have an unpleasant taste, which we don't want. The food and beverage industry heavily relies on pH control to prevent the growth of harmful bacteria. And pH affects the taste, texture, and also the shelf life of the things that we like to eat and drink every day. Agriculture, so crop growth, for instance, soil pH. The pH of a soil will determine its nutrient availability. So the example I have is blueberries. They need acidic soil, while cabbages prefer a neutral soil. So it's important to monitor the pH there. In the pharma industry, measuring and controlling pH is critical because even slight deviations can compromise a drug's or a medicine's performance and safety. The pH can directly influence how medication is manufactured, how long it lasts on the shelf, so its shelf life, and how it behaves once it's inside the human body. Wastewater, the sewage water that is checked before discharging into any nearby water body. So the pH level of the sewage is important, and that is to prevent damage to aquatic life and to protect the environment as best we can. Cosmetics, pH testing is a fundamental QC step because it makes sure that the products are safe for the skin. Make sure it's stable on the shelf, and they can effectively deliver any active ingredients without damaging the skin. Nobody would, we don't want to put anything too acidic or too alkaline on our skin on a daily basis. Chemicals, raw materials, and end products are checked during the quality control process to make sure the products, to check on the product purity and the stability. Education and unis, so from all the way from early years, maybe using pH indicated papers like litmus paper or even red cabbage juice, just to provide a clear visual of different pHs. And then in later kind of years, developing lab skills, possibly learning to use and calibrate a pH probe, various student experiments you can do, such as how does acid rain affect seed germination, for instance. So lots of uses in the universities, and there is lots of other reasons we won't go into. Medical uses, the pH level of paint, it can affect its properties, so the viscosity, its drying time, the color. So next time you see a really beautifully painted wall, you remember that there was an important step in the QC in the manufacturing process, that the measurement of the pH was checked to achieve that lovely finish you've got on your walls. So there's lots and lots of uses, and where pH is measured. So the measurement principle is pretty simple if we kind of dial it back a little bit. The pH value is measured by potentiometry. So think of a pH meter like a specialized voltmeter. So the voltmeter or the pH meter is in the middle, and then you've got your reference electrode, and you've also got a measuring electrode as well. The measuring and the reference electrode are in the solution and they are in contact with each other via the sample solution, and that completes the circuit of the voltmeter. And then the difference between the two electrodes is measured, and that will give you your pH reading. In the past, there may or may not be anybody that would remember back in the day, way back when, you would require to have two separate electrodes. So you would have one measuring electrode and you would have one reference electrode. But now most modern sensors, with the improvement of the manufacturing techniques, most modern sensors are combination electrodes, which simply means that both of the components, so the measuring and the reference electrode, have been squeezed into a single body. And that is generally the all-in-one probe that you will see every day now in modern labs, schools, and in factories. So on this picture here, you've got the measuring electrode in the middle, and then on either side, you've got the reference electrode. This one has an integrated temperature sensor as well. Not all electrodes have that, but this one does. So that's what that other white dot above there is. But essentially, the majority of the probes that are used now in schools are going to be the combined electrodes that have the measuring and the reference electrode in one. Quickly look at the reference electrode. So the reference electrode acts as a constant part of the sensor. It is designed to maintain a stable and unchanging electrical potential. Typically, they use a silver chloride wire, which is immersed into an electrolyte such as potassium chloride. And this electrolyte solution must be able to flow out freely from the sample junction, which is located at the tip. So it is really, really important to keep that reference electrode, the reference electrode clean, and the sample junction clean as well, to allow the electrolyte to flow out through the junction. The measuring electrode, you have inside, you have the lead-off wire, which is immersed in the inner buffer. And then this lead-off wire carries the electrical signal, or the voltage, to the meter. You've got the glass membrane, or the tip. We'll call it the glass membrane, the tip, either or really. The tip, it's made of specialized pH sensitive glass. When it's dipped in a liquid, a thin hydrated gel layer forms on the outside, and hydrogen ions in your sample react with this layer, creating the voltage essentially that the meter reads. So the glass membrane is kind of the most important thing on the electrode. We mentioned that the special type of glass reacts with an aqueous solution, and it forms a gel layer. So you will form a gel layer on both the inside and on the outside of the glass. And that gel layer acts like a sponge for hydrogen ions, or H+ ions. And those H+ ions can either diffuse into, or they can diffuse out of the layer, depending on the pH value. So if you have an acidic solution, there's lots of H+ ions swarming into the glass, creating a positive charge. If you have an alkaline solution, then there are fewer H+ ions present, and that results in a negative charge. This gel layer, because it is it's very sensitive, it is important to keep the electrodes hydrated and iron rich for accurate measuring. So good practice when you are testing pH of a solution. What kind of accuracy can be expected when you're measuring pH? Well, that all depends on a number of factors and how well the meter and the probes have been looked after. So for instance, the sensors, are you using the correct type of sensor? Have they been calibrated regularly, and have they been maintained appropriately? The sample, is it the correct size or volume? Is it the correct consistency? Is it the correct temperature? Or is the temperature of the sample known? The proper handling of the meter, sensor, buffers, and sample. in the correct environment? So are you maintaining a constant temperature and you're away from any sort of dramatic airflows? The meter, has it been calibrated? If you're using an external temperature sensor input, has that been calibrated as well? And your methods, so your sample preparation, the endpoint algorithm, your stirring speed, and all of that. If you are doing all of this to the letter and correct, realistically, all the best pharma labs in the world that are manufacturing all these drugs that we administer daily, realistically, you can only maintain or create an accuracy of plus 0.02 to 0.05 pH. So realistically, if you're doing everything right, that is the realistic accuracy that you can be achieved. Before the next slide, I just want to ask if you can pop in the chat how old, if you're using pH probes in the classroom, how old are the probes in years? If you're able to put any numbers in the chat, just because we'll just have a little brief look at some of the ages of there. So what do we have, 10 to 20 years?
Yeah, 15 to 20, at least 10 years, 2 years.
Yeah, 2 years, 2 years, 15 to 20. So some 10 plus 12, 1 to 2 less than a year. Wow. Okay, so 10 to 20, some must be 20 years old then. So 20 years we've probably got as the as the oldest probes there. So this next slide might shock you then. The lifetime of a pH electrode. So the longest lifetime of an electrode is reached when you've done everything correctly to the letter, when you've stored it properly, when you've maintained it properly as well. So you've been calibrating it, it's been stored correctly. If you're measuring in aqueous solutions, which I'm assuming 99% of the samples that you're measuring are going to be aqueous solutions, because if it's not aqueous solutions, you probably need a specialist electrode or a different type of electrode. And if you use it within the range of pH 1 to 12. So these are approximate lifetimes that are suggested for pH probes. So if you are using testing samples at ambient temperature, then the approximate lifetimes is suggested between 1 to 3 years. If you are using your electrodes at 90 degrees or up to 90 degrees, the lifetime of the probe will dramatically decrease down to around 3 to 9 months. And if you're using it at 120, it could be a few weeks. And the reason on the temperature affecting it is because we mentioned the membrane or the tip has a lovely gel layer that's iron rich. If you're submerging your sample, your electrode into samples that are high temperature, that gel layer is going to become damaged and it's going to become frail and it's going to become dry and crispy and it's going to deteriorate quite quickly in high temperatures. So how to look after your pH sensors. So sensor storage, proper storage, make sure that the pH sensitive gel layer remains hydrated and iron rich. So this is the glass membrane or the tip or the bulb. Either description is fine. And inside that is that lovely gel layer, and it needs to be kept hydrated. It needs to be kept iron rich, and to do that, you should keep that in a special storage solution. So you can buy very expensive special storage solutions on the internet from your educational supplier. You can use that, or you can just use an electrolyte solution, 3 molar KCl. That is what the electrolyte is used in a lot of the pH electrodes is. So you can use an electrolyte solution. You can make up your own solutions of 3 molar KCl. If you don't have any 3 molar KCl, you can store it in a buffer solution. So you can use a pH 4 or a pH 7. and you can store your pH probe in those. Or in a diluted HCl solution, hydrochloric, so about 0.1 molar. So any of those you can store your solution in, your electrodes in. How do we store them? Whenever you buy a electrode, it should be supplied with what we call a wetting cap. And the wetting cap is designed to hold. So our wetting caps have a little tiny sponge in the end. And these are designed to be cleaned and then replaced with the recommended storage solution or electrolyte solution. So you can pop a few drops in there and you can pop the lid on, and that will make sure that it keeps the electrode in the glass membrane nice and hydrated and iron rich. Never, ever, ever store it dry, because you will affect this gel layer. Never store in distilled water, or never store in non-aqueous solutions, because that will just reduce the lifetime of your electrode. If you've allowed your electrodes to get dry, so you found one on the desk the next day and it's gone dry, we can recondition them. So I will go over some tips on how you can recondition the pH electrodes before you write them off. So never store them dry, never store them in distilled water. It needs to be in this nice iron-rich solution.
Got a question for you, Hayley.
Yeah.
We have been storing in contact lens solution. Is that okay? In
contact lens, so I don't know what contact lens solution consists of, actually. So keep that down, and I'll double check. I'll double check that. Replace the storage solution. So the storage solution that you have, over time it can evaporate, it can become stale, it can be dirty, it can get bacteria inside. So it is recommended to replace the electrolyte, the storage solution. Replace it once a month with fresh solution. Even if the meters are not in use, it's always good practice to not top up. We would replace it. So wash out the wetting cap, pop some fresh solution in, and it is recommended to do that once a month. This is all to get the best and the longest life out of your electrodes. Sensor preparation, so the reference electrolyte. I'll scoot over this quite quickly because it may not really relate if we've got a combined electrode that is not refillable with the reference electrolyte. But you can have reference electrolyte that can either be liquid or gel filled. Gel filled ones are easy to maintain, but they can be a bit slow and they can be a little bit impossible in certain tricky samples. But for general aqueous solutions, should be absolutely fine. And you can get liquid filled electrodes that do offer longer lifespans, only if you care for them correctly, and they do take a bit more looking after. For the liquid reference chambers, for the liquid reference, the chamber needs to be properly filled with clean electrolyte. So again, I don't think, I'm not sure if you've got any users on today that have liquid filled reference electrodes, but if you do, you have to replace the electrolyte once a month. Again, don't top it up completely. Release everything that's in there, give it a rinse, and then replace it with fresh reference electrolyte regularly. The electrolyte level must be higher than the level of the sample. There is another picture on one of the slides which I'll show you, and that ensures that the electrolyte flows into the sample and it stops any contamination. And it avoids crystallization and impurities of the electrolyte as well. And also check for air bubbles behind the junction. So a little bit of shaking kind of side to side usually would generally get rid of any air bubbles in the reference. pH sensors, so how to clean them. After you rinse the electrode before and after every measurement, and before and after every calibration step as well. Always rinse with distilled water. So you can use a wash bottle with distilled water and just give it a squeeze over a beaker. And then tap it or dab it. I don't know why that says dip it, apologies. Dab it dry with a paper towel. So never rub your electrode, never ever rub, because that would cause static and it will give you, your readings will be all over the place because you're generating electrostatic charge on the electrode. So a paper towel, all you need to do is just dab it. And again, never rub it and never wipe it, just dab it. For non-aqueous or dirty samples, first you can use a solvent, so you can use acetone or ethanol to get rid of any dirt which isn't soluble in water. But once you do that, you should immediately then rinse the solvent off with distilled water, and then you must pop it back into an aqueous solution. So condition it in your 3 molar KCl, pop that back in your storage solution, just to make sure that any dryness that's occurred from the solvent is rectified in the solution. So pop it in your conditioning solution or your storage solution. And again, do not wipe the probe, just dab it dry with your towel. Sensor calibrations. So your pH sensors must be calibrated regularly. It is always advised to do a minimum of 2-point calibration. And when we say 2-point calibration, we mean at 2 different pH levels. So you can do it at pH 4 or pH 10. And it's generally advised, if you know the expected pH of your solutions that you're going to be sampling, try and do your pH points either side. So if you're measuring something of a pH 7 in value, then you can calibrate it at pH 4 and pH 10, just to encompass the expected sample of the pH. The conditions at calibration and measurement should be equal. So you should always measure your sample and calibrate at the same temperature. So make sure your solutions are at the same temperature. And what that means is don't use your calibration solution. If you keep it in the fridge, take it out the fridge, bring it up to room temperature, the same temperature as your sample, just for accuracy. Always use fresh buffers, because accurate buffers equals accurate calibration, and that's accurate measurement. And if at all possible, if you are able to calibrate it 3-point calibrations, then it is always recommended, but a minimum 2 points should be good. And possible errors you will get if you are measuring your samples at different temperatures that you've calibrated at. So that can cause potential differences, because we'll talk about later on, pH can be affected by temperature of a solution. So always make sure that you're calibrating at the same temperature as you're measuring your solution. And you might get contaminated buffered or wrong buffers if you get any errors during calibration. But the pH solutions, so we are owned by Metler Toledo, so we have our own range of very, very expensive pH buffers. They should only be used when you are purchasing them ready to use off the shelf. They will have the pH buffers are only guaranteed before the expiry date is reached. So make sure you're not using any pH buffers after the printed expiry date on the label. So don't order in bulk if you are ordering ready-made ones. Store bottles in a well sealed at room temperature. Only take out the amount needed out of the bottle and then close the bottle again to avoid any contamination. Never calibrate the electrode directly into the bottle, so always take your buffer solution out of the bottle, and then never reuse the buffer that's already been used either, and never return the used solution back into the bottle. And consider using single.
Got a quick question, Hayley, sorry.
Yeah.
How about pH tablets to make up buffers? Are they okay?
Absolutely, yes. I was just going to say the buffer solutions can be quite expensive, and if you're not going to be using the pH buffers too often, I absolutely recommend using the pH buffers the tablets. So they have a longer shelf life. They can sit stable on the shelf for many years. And the good thing about those is you can get the one tablet off the shelf, and you can make up your buffer, and you can use your buffer as and when needed. So yes, we do recommend, for the cost purposes as well, they are much more cost effective option, and I'm sure you can get those from Timstar, the calibration tablets.
Yes.
So Timstar can provide you with the calibration tablets.
I've got another question. We have some sachets from about 10 years ago. Will they still be okay to use?
So there should be a date on the sachet, an expiry date. You should, as long as they're still in date, they'll be fine to use. But they wouldn't be suitable to use after the expiry date.
Perfect, thank you.
No problem. So just a little bit of sensor troubleshooting then. So if you're having any issues when you're trying to calibrate, then there could be something else wrong that could be rectified. You may have a contaminated membrane or diaphragm, and problems like this show unstable or show readings. So there's a couple of other options that you can go for a bit of maintenance. If your electrode is blocked with silver chloride, for instance, you can use concentrated ammonia to give that a clean. Then just pop the concentrated ammonia, give that a wipe, and then afterwards distilled water as well. If your probes are blocked with silver sulfide, you can clean with an 8% thiourea in a 0.1 molar HCl solution. If you've got samples that are high in proteins, then 5% pepsin works in 0.1 molar HCl. And if you've got something that's really sticking in the junction, and your blockages, you can't clear the blockages of your junctions, what we suggest is popping your electrode in your electrode cleaning solution, so whether it be the pepsin or the thiourea, into a beaker, and then put that beaker into an ultrasonic bath, and let the ultrasonic bath do its work, and that should agitate anything that's blocking into the junction, and that should release that and hopefully get that clear. With these solutions, it's recommended that you treat them for 1 hour, so you can leave them immersed in the cleaning solutions for 1 hour, take them out, rinse them with distilled water, and then, because you've changed, because you've maintained that, you need to perform a brand new calibration. Hopefully that would get your probes working again. We mentioned about pH sensors being dry. So if you have left your pH sensors on the bench, or a student has left the pH sensors on the bench overnight, over the weekend, it's not it's all is not lost. We can just try and recondition the membrane. So you can get a dry membrane if you're measuring in non-aqueous or iron deficient media or solutions. If you've put it in the wrong storage, so if you've stored it in water, for instance, or if it's just an old sensor. An old dry membrane will result in reduced sensitivity of the glass, and the gel layer inside is just washed out. It gives unstable readings, so we can try and condition it. You can condition this in a 0.1 molar HCl solution for 12 hours. So you can pop that in overnight, leave that in that solution to really try to hydrate and reactivate the membrane. If that doesn't work, if there is a really kind of mild hydrofluoric activation solution that you have, or that you have access to, you can pop it in that solution for 1 to 2 minutes. 1 to 2 minutes only, and then you need to take it out. You need to then rinse it with distilled water, and then you need to recalibrate. If neither of those things work, it may be that the electrode just needs to be replaced. Good measurement practice when you're taking the sample is making sure that the sample is the right consistency. So it's always important before you do your pH testing to stir the sample to make sure that it's all homogenized. Then once you've stirred the sample and it's all homogenized all nicely and mixed up, you can then switch off the stirrer and then you can measure. If your method requires DIN 19268, which does state that it needs stirring, then it's recommended you can just stir it gently. So by that we mean just pop your probe into the solution and just give it a little stir, just like that. So not like you're cooking, stirring the chili on a Saturday night, just a little gentle stir and that should be fine. And always make sure that you do whatever you do for the calibration, you do for the measurement and vice versa, just because it needs to be consistent in the way that you're taking your measurement samples. Temperature. So we did touch on briefly that you do get electrodes that have an integrated temperature sensor. Now, this is because pH is directly affected by temperature. So knowing the temperature of your sample is critical for accurate readings, really. There's two ways you can do this. You can get you can have electrode that has an integrated temperature sensor, which would be in the shaft with the measurement and the reference electrode, or you can connect or you can use an external temperature sensor. So either way, if you're using an external temperature sensor, and you know the temperature of the sample, you may need to manually enter the temperature on your pH meter. Generally, they are set to around 25 degrees, but if it's anything different to that, you can manually pop the temperature in the reference into the electrode, and then that will use the built-in algorithm to determine what the pH is based on that temperature. If you've got an integrated temperature sensor, then that will work it all out for you. And you'll see on this one here, it has got the temperature showing as well as the pH value. Again, make sure the temperature of your calibration buffer and your sample is identical. And that, yeah, just to make sure they're measured at the same temperature.
A quick question, Hayley. Sorry.
Yeah.
How can you get rid of the black mold attached to the probe, please?
Black mold attached to the probe. We could try. Well, what kind of solutions have you used to try to clean the electrode? Because it may need to be soaked. For mold, I am not 100% sure. I'll double check which solution would be the best. But what solutions have been used to try to get rid of the mold?
And that's
the problem with
to Wendy. Wendy, if you can put a little message in the chat.
Yeah. So the reason mold may be forming is it's sitting in old electrolyte storage solution. We mentioned about replacing the electrolyte storage solution once a month, and this is for reasons like this. The solution can get contaminated, it can get dirty, bacteria can grow in there, and it can cause molds and all sorts of other nasty things in there. So that's why it's recommended that you do change the storage solution at least once a month, which I know in certain circumstances can be quite difficult to do.
Got another question for you, Hayley, from Denise. I'd like to do a pH probe MOT each summer holiday. Would just reconditioning and recalibrating be enough? They're usually just used to check the pH of common household items.
Yeah, that should be fine, as long as I say, as long as it's been stored in the appropriate storage solution. So that's key. The 3 molar solution, the electrolyte storage solution, or the pH 4 and 7 at a push, but make sure that it is stored correctly. And then, yeah, before you do it once a year, get them out the day before your lesson, your lecture, and give them a clean, recondition them, another clean, then recalibrate, and then clean them again in distilled, and hopefully that should be enough to get them up and running.
Just come back to the question around the mould. Wendy's come back and says they're stored in pH 4 buffer and are very old.
Okay. So yeah, it would be a case of replacing your electrolyte storage solution, and then I'll double check which of the solutions would be best to get rid of the mold. But you could try the storage solution and soaking it in that, and then try and giving them a clean. And obviously remember, don't try not to rub the electrode, just dab them, just so not to cause any kind of electrostatic on the junction or the electrode.
On the maintenance sheet, it says to soak a dried electrode in distilled water.
No, we would not ever recommend to soak in distilled water.
No, so no. That's a no-no.
Yeah, the solutions that you're soaking need to be iron rich. They need to have lots of those H+ ions to keep the gel layer nice and hydrated and iron rich.
Thanks, Hayley.
Okay, so we'll carry on. I'm conscious of the time. So we did mention about refillable electrodes. So this is one of our refillable electrodes from our parent company, Metla Toledo. And this is what we mean by refillable. There's a little bung here that you can open. And once it's open, if it's not in a solution, all the electrolyte will fall out of the junction. And then you would re-clean that, and then you would refill it with the electrolyte solution. Just double check when you are measuring the sample. Is the temperature stable in the sample and the sensor? Is the electrolyte higher than the level of the buffer or sample level? So this would mean that if your sample level is here, you need to make sure your electrolyte is higher than that sample level. Is the junction completely submerged in the sample? Did you stir the sample to make sure that it's all nice and homogeneous? And did you open the refilling hole? When you have a refilling hole, it's important to open that once it's in the sample, just to make sure that the electrolyte can flow out of the junction. pH measurement practice then. So this is just a little bit of a simple checklist if things go wrong. Check to make sure that your filling hole is open during the measurement, if that's applicable to that type of probe. Check the storage is correct with the correct electrolyte. Dab clean the glass membrane, never rub. Calibration regularly. So if you're using the pH probes daily, it is recommended use daily, but calibrate it before use. Make sure there's no external temperature influences affecting the measurement. So make sure you've calibrated at the same temperature as you have measured your sample. Replace the electrolyte regularly, if applicable. Make sure you use new buffers for calibration and you're not using any old buffers, and it's got to be fresh. And keep stirring to a minimum during measurement as well.
Got a quick question, Hayley?
Yeah.
What is the recommended storage temperature below temperature in the winter?
Well, we just recommend kind of it's ambient room temperature really, for correct storage.
Okay.
Yeah.
Perfect.
Yeah.
Yeah. That's fine. Thank you.
So this is another a continuation of the checklist. If anything goes wrong, just be prepared. So we have the question about, can I recondition and calibrate once a year? Absolutely. Try and you do this the day before you need to use them, so that if you've got any issues, you can try and rectify them. So use the pH meters the day before, make sure that they've been calibrated, and if needed, condition them, clean them, recalibrate them. Bit of a checklist here. If they don't work, you can revive them in your 1 molar HCl for 12 hours. Again, recalibrate. If you've got any that are particularly dirty, you can put that solution into a beaker, into the ultrasonic bath, to really agitate any dirt and grime away from the electrodes. Make sure your calibration buffers are fresh. So they can be fresh out of the bottle, or they can be freshly made up using the buffer tablets. And refresh your storage solution once a month. And also, if you have the refillable electrodes, make sure you replace the electrolyte with fresh new electrolyte once a month as well. And this is just an overview of the pen meters that we have in the OHAUS range. So we have the pH, the orb, conductivity, salinity, TDS, and DO. Simple operation, IP67, they are very robust. The good thing about our electrodes here is that all of their units have a replaceable electrode. So the electrode here is the part that gets worn and will need to be replaced. And the good thing on these is they are fully replaceable. So you keep the measurement part of the electrode, and you just replace the electrode once it's been worn. So it's good from the sustainability aspect. You're not throwing a lot of the measurement electronics out into the landfill. You can just simply purchase the electrode, and it will be half the price of what the complete unit would have been. You have the storage cap, so that's got the little sponge in the bottom that you can pop your storage solution in. And you can close the lid and you can store them correctly. They are gel filled, so they are easy to maintain. You're not going to be having to refill the electrodes with electrolyte, so it's all encased in here, so you don't have to worry about that. You do have a nice hard carry case with them and a wrist strap. For pH, we have two. We have one which is an ST10, which is just for simple pH measurement. You can't calibrate them, so you literally just pop it in, look at the number change, give it a clean, and away you go. The ST20 has an integrated temperature sensor, so you've got the temperature reading on there, and you can also do 3-point calibration as well. And you've got here just a little bit on the accuracy. It's got automatic shutdown as well. So after 6 minutes of non-use, it will switch off. You've got different buffer groups as well for the ST20. The batteries now, I mean, they are completely replaceable. You unscrew the top and you can just replace the batteries. You've got 4 little batteries in the top there. Now, the sensors that I've got in my demo kit years and years and years old. I've never had to change the batteries in any of these, so they are really, really, they really do last. I don't know how much time we've got, Lucienne, because I do have a little video on how the pH meters can calibrate, but if we've not got time, that's fine. I can send you the slides anyway. Pardon?
Still get 6 minutes.
Shall I just play this then? I don't know if the sound's gonna be. Is the sound on?
No sound.
Okay, so I don't know how to get the sound on. So I can just talk through it anyway. So this is the ST20, and this is going to show you how you can calibrate the ST20 pen meter. As you can see, we've got our pH buffers already there. We will remove the protection cap, and we've got distilled water, and we're just going to give it a rinse. So this is all you need to do to clean them. Rinse it with distilled water, and then gently just dab the end with a paper towel. On the meter, you will switch it on, and you will press the cal button, and it will know what pH, it will blink, and it will know what pH buffers you need, and it will automatically start. It will start with the pH 7. So you'll notice it's given a gentle stir, and you just leave that in the beaker and that will calibrate. Doesn't take too long. Do apologise, there's a nice little tune playing in the background my end. So when it's calibrated, it will automatically flash up with the next pH buffer, which is 4.01. So what you would do then is you will take that out. You would use your distilled water to give the electrode a rinse, dab it with paper towel, and then you would just pop it straight into the pH 4, little stir, and again we will just leave that to calibrate, to recognize the pH 4 buffer, and what will happen next is it will flash up 10.01 once it's calibrated, and then you will just repeat, rinse the electrode, dab it dry, and pop it in the pH 10. So I'll leave that running in the background. So that's essentially how quick and how easy the ST20s are to calibrate. So I think that will be everything from my side. If there's any questions, Lucienne.
No more questions. Anybody got a question out there for Hayley? What do they retail at?
What do they retail at? So you might need to help me here, Lucienne. I believe the ST20, which is the ones that you're seeing on the screen that you can calibrate with the temperature sensor, I'm going to say it's around £100. And then if you need to replace the sensor, it would be half that. So it would be around £50 for the sensor.
Yeah. ST20 is £115, and I'm just looking for the other one. See if I can get it for you.
So the ST10 would be slightly more cost effective, as again, you don't have the temperature sensor and you're not able to calibrate those ones.
Yeah, ST10 is £54.95.
There we go. So to replace the electrodes is roughly half of the price of the full unit.
We're going to do a bit of a prize giveaway. We're sort of factoring this in at the end of our sessions just to sort of keep people to the very end. So the first person to answer the question right will get a voucher. So this is just to test whether you were listening to Hayley the full time. So the first question is, what do you never store your pH probes? How do you never store them? What's the answer? I've got an answer here. It was dry that I was looking for. So the first person on the chat, I will have a look back because there's lots of answers coming in now, to look back to see who that was, and there'll be a voucher winging its way to you. The next question is, how often do you replace electrolytes? Oh, we've got an answer straight away, monthly. Catherine, just quickly saw that. Catherine Groves, there is a voucher going to be winging its way to you into your email inbox. So thank you for that. And the last question I am going to ask for the last voucher giveaway is, how often do you rinse the electrodes? How often do you rinse the electrode? Just have a looking down the chat to see. We've got a before and after. It's Miss N Benjamin. We've got before and after every measurement, so well done on that as well. And we will send your vouchers out after. You'll also get a certificate of attendance, which will cover any CPD. I hope you enjoyed Hayley's session. I found it really good, Hayley. It was absolutely fascinating and very informative, so thank you very much.
No problem. I think there's a few questions in the chat, and we can get back to you. So there was one, the slide said 0.1 molar HCl for reviving, but I said 1 molar. It is 0.1 molar. So apologies if I said that wrong, but it is 0.1 molar HCl.
Perfect. I jotted it down just in case.
Oh, okay.
We were
If
coming
there's
back
any more
to
that pop up, we can get back. Lucienne can get back to you. That's not a problem.
Yeah, we'll get the people have asked for the PowerPoint as well.
Yeah.
Hayley, would that be all right to send on?
Absolutely, yeah, I can forward that on. I'll send it to
Perfect.
you, Lucienne, and you can distribute that to everyone.
Excellent. So we'll get that along with the certificate. I'll send the vouchers out for the prize winners as well. So thank you very much, everybody, for attending, and look out for the next one next month, which will be on BMS microscopes. So thanks, everybody. Thanks for attending, and see you next time.
Thank you.
Bye.
Thank you. Bye.
Bye, everyone. See you next time. Lots of fabulous messages of thanks. Really appreciate it. Thank you, everyone. Thanks for your attendance. And we'll get the videos posted online as well, so that you can refer to as and when, if you need it to view at any time. We're trying to get our videos uploaded onto the website, onto the Timstar website for you. And if anybody's got any other questions to ask, if not, have a lovely afternoon and see you next time. Bye.